So this is the site that we moved to in 1986. Previously, the company had been based in Bethesda, and it was formed in 1981. Although there's quite a rich history of manufacturing in North Wales. There was a company called Clogwyn climbing gear based up here that ran through the 1960s and 1970s. And the owner of that eventually founded what was to become DMM Engineering and DMM International. And here we are. What better place to be based, actually, right at the base of Wyddfa or Snowdon, our highest mountain, or the highest mountain in England and Wales, actually. And we're going to go and have a word with Brian, who's busy at work actually polishing some of the die blocks that we'll use in production. He'll be using a series of grits from coarse to fine until the surface of the die block is absolutely mirror smooth, because any imperfections in that will actually manifest themselves in the product itself. The die blocks themselves are really expensive, or relatively expensive, but bear in mind they could actually last many years, 10, 15 years, depending on the product and depending on the complexity of the product. So after the bars have been cut to the right length, we're now looking at the bending or bowing. The material itself is an aluminium alloy, 7075, which is widely used in the aerospace industry, used in mountain bikes, things like that. It's very tough and very ductile. And as you can see here, there's no heat employed here. We don't need to heat the bar. It's bent cold because it's ductile enough. And every carabiner we make will come through this machine. Once the preform has been bent, we then go on to the forging, which you can hear now. And the forging process is very precise. The preform has to go in the oven to be heated to the correct temperature. The die blocks themselves have to be heated to the correct temperature. And then it's one simple blow for this carabiner, which will turn that round bar preform into the complicated shape you can see now. We have to clean the die set between each blow to ensure there's no slaw left in that could be forged into the next unit. So it looks a very brutal process, but it's very precise. The temperature's precise. The pressure we're forging at is precise, the speed, the blow, all of that. So the round bar preform shape that you saw before, 30 or 40 years ago, that would have been the carabiner, that would have been the shape of the carabiner. But over the last 20, 25 years, we've developed hot forging processes which achieve certain things. We can take a lot of metal away from the product to make it lighter. We can move metal around the product into crucial areas, important areas like where the rope radiuses are or where stress points are. So in one blow, we've removed metal to make it lighter. We've made nice big round rope radiuses. We've forged the nose, we've forged the hinge, we've forged the branding, and that's all in one blow, one hit on the forging die. You wouldn't be able to do that any other way, certainly not affordably. So once it's forged, we need to remove the outside part, or the flash, and this is the same process. It's a different product. These are the cam lobes for our Dragon cams, but it's exactly the same process. We're punching the product through the middle of the tool and removing the excess. All the excess will be sent away to a recycling company, so we can sort it into different materials, into aluminium, into steel or stainless steel, and that can then go away for recycling. We can't actually reuse it ourselves, but it will come back as different things, window frames, Coke cans, or something like that. So we're now coming down to the heat treatment area, And this is probably the most important area of the production. As you've seen by now, we can make the product any size, any shape, but if we don't make it strong enough, we may as well make it out of chocolate. So the heat treatment is a little bit like hardening and tempering of steel, but for aluminium. And it's a two-part process. We heat the product up very close to its melting point. It's heated in an electric oven and held at a very specific temperature for a very specific time. At the end of that, we'll open the furnace and we'll quench the product in water. And if we left it at this temperature, this ambient temperature here, the product by itself would get harder and harder and harder over a period of time. But we then accelerate that process, because we can't hang around forever, by artificially aging it. And that is to get the product to the hardness that we want, that we require to achieve the strength. Now, both these processes are completely controlled by a PC. We're working between plus or minus 1 degree Celsius, and the times and the temperatures are absolutely important. They're crucial in terms of getting the right strength. So we'll take a look at the two big solution treatment furnaces here, and these will actually accommodate up to 4 batches of carabiners. That's over 3,000 carabiners. So this is the actual furnace, and this is the quench tank, and the product will come out of the furnace and into the quench tank in a very short space of time. The furnace itself is electrical elements around the outside and a fan to circulate the air on the inside. So this will demonstrate what a CNC machine, or computer numerical control, can do. Here's the forging, forged just like the carabiner was forged. It was clipped just like that cam lobe was clipped, and all the edges smoothed over, just as you've seen in the last process. We now need to do some more operations, and so 12 of these will go onto the machine and 12 of these will come off. So here we are in the main assembly area, where we will literally assemble the product, whether it's a carabiner, a cam, an ice axe, a pulley, or whatever. And once the carabiner is assembled, once the gate, whichever sort of gate it's got, has been assembled, in this case it's a wire gate, 100% they will all end up on this table and they will get rectified, which is just tweaking the gate action to make sure it's absolutely silky smooth. So when you pick it up in the store, you think, that's pretty smooth and works really nicely. And this is 100% for every single carabiner we make. So here we are in the assembly area, where we're assembling a straight gate onto the DMM Shadow carabiner. As you can see, this consists of a plastic spring pusher and a spring that's located in the gate itself. And then the gate is located onto the back of the carabiner. And once it's in position, we'll move then on to riveting. So the rivet is inserted into the hinge hole that has been pre-drilled in the gate and in the carabiner back. One end of the rivet is already pre-formed so that it can push through from one side. And once it's fully through, we can actually take it from here to rivet the unriveted end so the rivet can't fall out. The rivet acts as the hinge for the carabiner to open and shut. So this is one of the last processes that we carry out, and this is the laser etching. And as you can see, we laser etch certain information that we have to put on the product by law, and certain things that we ourselves want to put on. So we've got branding, we've got the relevant standards that the product achieves, and But also very importantly for us, we've got a unique serial number. So as you can see here, this series of numbers that starts with 25, that's for 2025, and then 296, which is the 296th day in 2025. And then the next 4 digits are unique to this number. So no other carabiner in this batch, none of those will have the same 4 digits at the end of that serial number. This is important so that we can have complete traceability of all our products and can trace this back to the raw material that it was made from, and also who did what on what day and what machine, right through every single process that you've already seen. Here we are now in final inspection. So this is a 100% process where we're inspecting the product, we're looking for mechanical defects, structural defects, and cosmetic defects. And at this stage, any of those will be taken out, and if they're serious enough, we would quarantine the batch and find out what has gone wrong, if anything has. That very rarely happens because of the controls you've seen all the way around up to here. So this is a DMM Seros carabiner with a captive bar, and we're just going to do a major axis destruction test on it. So the carabiner goes into the test machine and is held on 12mm pins, top and bottom. And once it's located correctly, a little bit of tension is applied, and then we're going to pull it at a specific speed as prescribed by the standard. And what you'll see is that the carabiner back, because of the heat treatment being so good, will actually start to stretch. The aluminium is still quite ductile. If it was too hard, it would be brittle and we wouldn't achieve the strength. If it was too soft, it would yield well below the breaking strength of this carabiner. You can see the carabiner back now starting to deform. And we've actually broken the back at 29.1 kilonewtons. So here's the broken parts of the carabiner, and as you can see, if we inspect it, we're looking for a very nice fine grain structure, which would be indicative of the heat treatment having been carried out correctly.